I've finally done it. Except we can keep hearing a double sound, so we'll turn that off. Okay, here we go. So we're in 5.2 today, and actually, hopefully 5.2 won't take tons of time. But and again, I want to give you a bulk of time in class to work on stuff, so hopefully then you can take advantage of that and get most of this done. I did not mean to I felt like I shortchanged you last Wednesday. I gave you too much time up front on the front end, and we killed too much time. And actually, that was a beautiful example of me killing your time just now. I'm sorry for not being organized enough to get this straightened out. But I want us to get our big ideas and the worksheet done in class. So a system of linear equations, we talked about that. It's a system is going to be, I could write, my pen would write, two equations with multiple variables. And I should actually say the same two variables. So like 4x plus y equals 7. And 2x minus y equals -1. That would be an example of a system of equations. Do you remember what the solution to a system of equations is? We talked about it last week. Was anybody not here last week? Last week. Last time. Anybody not here on Wednesday? I think you were all here on Wednesday. Any takers? What did we find last time? That's it. Okay. Can we be a little bit more precise about what exactly is the solution? We tested it to see if it was a solution, but what is a solution to a system of equation? It is a point that does what? Go, Paige. Sorry, what? It is the intersection of the point, the intersection of the two lines. True. But I'm looking for what exactly is the solution. The solution is the point that does what? Makes both equations true. Okay, that's what we're finding. When we find a solution, we are finding a point that makes both solutions true. So in this case, if I did it in my head correctly, I think this should be 1 and 3. And we can test that out here in a second. All right, we'll test 9. We'll test it out here in a second. Okay. Let's scroll on down to number 1 and talk about how we're going to do 1, 2, and 3. Now, I want to solve an equation. When I solve an equation, it's easy to say. If I gave you an equation and I said x plus 4 equals 5, and I said solve that equation, what would you do? You would subtract the 4 over and get x is equal to 1, and we've solved it. It was easy. There was a specific answer. X equaled 1. Now the problem is, over here I have this equation, 2x plus 2y equals 10. And if I said solve that equation, you'd tell me for what variable, because that's the only thing you can do is solve for a variable. I cannot come to a specific answer because I have two things that can change. So that is the inherent problem when I talk about a system of equations. My system of equations has multiple variables in it. So I have to figure out a way to get rid of my two variables. And the method that we're learning today is substitution. Okay? So what does substitution mean? Let's go. Right, if we're talking about variables and numbers, we can substitute something in place of. So if I go to the store and I'm trying to buy my Fruit Loops, but they're out of Fruit Loops. I'm going to have to substitute something else in my breakfast cereal place. So I'm going to have to put Captain Crunch in its place. Okay? If I'm making something and I don't have enough of one ingredient, I'm going to have to substitute another ingredient in its place. So that's what we're going to do, except we're going to do it with variables. Okay? We're going to take variables and we're going to put variables in variables places. If that makes any sense at all, if I not, I just listened to myself. But remember, my inherent problem is what again? I have two variables. To eliminate that inherent problem, I want to get down to one variable. That's what we're trying to get to, is one variable. Now, if I come up here, I see that y equals x plus 5. So what I'm going to do is I'm going to do this. I'm going to write 2x plus 2 times y, but I'm going to substitute 5 plus x in the place of y. I knew that y equaled 5x, 5 plus x, so I'm going to put that in the place of y. Now, why was that helpful? How did that help me? How did that help me move forward towards finding the solution? How many variables do I have now? We have one variable now. So now I can solve for that variable. So now your algebra skills have to take over and win the day. So what do we need to do first here? Parentheses, very good. 2 times 5 is 10. 2 times x is 2x. That's going to equal 10. So we get 4x plus 10 equals 10. Well, this is a bummer of a problem to start on, but that's all right. I just don't like it because we're going to get a, oops. We're going to subtract that 10 over and get a 0. So I'm going to take 0 divided by 4 and get 0. So we have found out something. We have found out that the solution for this system of equations, if I would graph these, okay, it would happen at an x value of 0 and a y value of, how are we going to find that y value? Well, we know that y equals 5 plus x. Do we know what x is? We know that x is 0. So what happens if I put a 0 in there? Y equals 5. 5 plus 0 is 5. So that means, here, I'll put it in here because we really should. Y equals 5 plus 0. So that means that y equals 5. So that means the ordered pair for this solution is 0, 5. Again, I'm not showing you this so that you can, you have the tool now. I showed it to you already. And please just don't use it rampantly and force yourself into being not prepared to take this test. What am I looking for? This. I'm looking for that. But remember from last time, I showed you at the very end, we have 2x plus 2y equals 10. Okay, so if we graph that, there would be that graph. What was the other one? We're going to add to that another expression. Y equals 5 plus x. Now, what we talked about last time, the solution of a system of equations is where the two lines intersect at. Where did they intersect at? Here is 0, here is 5. So they intersected at the pair, at the ordered pair 0, 5. Then if we go back to my solution here, my solution is, why didn't you slide over? Oh, come on. There it is, 0, 5. So we are doing exactly the same thing. We're finding out the intersection, but we're doing it algebraically versus graphically. You have a way of testing yourself, okay, or checking yourself. I hope we do it. I'll work on it algebraically. So here we go. Let's do another one algebraically. Man, I put 6 in here for us to do. 9 of these for to do. Okay. So this is very, sorry, this is going to be very repetitive, but this is just the process of learning how we're going through this. We have 2x. I'm going to back up. I'm going to use a different color. So when we substitute, we want one of my variables isolated. So in the first few here, this is nice because they gave me, I got x is isolated, x is by itself. So this is what I'm going to substitute with. So we're going to take negative 2y minus 1, and we're going to close it in for x. So my next line is going to be 2 times negative 2y minus 1 minus y equals 3. Okay, so notice again what we did. We had x. Okay, we took this. We knew that x is equal to negative 2y minus 1. We took that and we substituted it in there. So here is 2. Here is x. Here's minus y. Here's equals 3. Okay, I know sometimes we'll forget to finish out the equation, but now we're ready to solve this. Again, we're going to take care of the parentheses. 2 times negative 2 is a negative 4y. 2 times negative 2 is negative 2. We have some y's to collect. That's negative 5y. In the same step, I'm going to add the 2 over. Okay, so we collected negative 4y and negative y. Since they're both negative, we're going to combine those together to get negative 5y. And we're going to divide the negative 5 across. So that means that y is equal to negative 1. Okay? Another one. Let's pick another color. Look at you. Forecast the future like that. Okay, so here's your choice. We have x equals, I am sharing my screen, right? I don't know. If it's messed up, I'll have to redo it. X equals y. So you have your preference. We could put y and we can make this x become a y, or I could make this y become an x. Okay, when x equals y, that makes it pretty easy. But I'm going to go with y minus 3y equals negative 1. Oh man, we're going to have to work with fractions. Nobody likes to work with fractions. Okay, what's y minus 3y? Negative 2y equals negative 1. You know what? Nobody stopped me. I still have work to do in red. All right, we'll finish that out. Okay, so since I got you going, what did I forget to do in red? I forgot to find what x is, so we got to find both of these. But now we have found y here. What is x going to be? And there's really no work to this because x equals y, so that means x is going to be 1/2. Now we'll switch back to red. So we know that x is equal to negative 1, so we can go with x equals negative 2 times negative 1 minus 1. So all we're doing again is we're substituting that y value that we found, we are substituting into my equation. So negative 2 times negative 1 minus 1. So this becomes a positive 2. That becomes a 1. So that means this is going to be 1 negative 1. Okay. 13. So obviously I skipped a little bit. We're jumping from 3 to 13. But that's okay. I don't think we're going to end up doing all of these. I think we're going to end up doing a couple more, then we'll work on your puzzle time one. Because I want to have as much class time as possible. So excuse me. Do you have to turn your head and cough into your sleeve if you have a mask on? Oh. Huh. Sorry, distracted. Squirrel. 13. What's my problem with 13? 13, we got to do a little prep work too. We can't just substitute and roll with it. What about 13 is different? We have equations, but we don't have anything isolated. We have 7x minus 4y equals 8. We have 5x minus y is equal to 2. Well, I can't substitute right now because there's no variable that's being isolated. Okay, there's nothing that I can just take and stick in. I've got to have an x equals or I've got to have a y equals. So I've got to figure that out. Now this one sets up really nice, and we have to choose, but do I want to solve for that x, that y, this x, or this y? Which one am I going to solve for? I'm going to tell you now, I'm going to solve for this y right here because it has a coefficient of 1. So if I can get to a coefficient of 1, that just makes things easier because I can probably avoid using fractions. Okay, so I'm going to take this equation. I know I need to end up with a positive y, so I'm going to add y to the other side. So we have 5x equals y plus 2. Now to finish that out, I'm going to have to do what? We need y by itself, so I need to subtract the 2. So 5x minus 2 is equal to y. Now we are ready to go. So what's my next statement going to start with? My pen will write a... We're going to go to the other equation. So 7x minus 4 times y, but I'm not going to write y. What am I going to write? I'm going to write 5x minus 2 equals 8. So again, that process is, we're going to take one of my equations, we're going to solve it for one of the variables. So we took this equation here, we solved it for y. So now we know what y is. Y is 5x minus 2. We're going to take that 5x minus 2, and we're going to put it in for y up here. So now, again, we go through that same exact process. We're going to distribute. So we get a negative 20x. We get a positive 8. And that's going to equal 8. We're going to collect some like terms. Please tell me I've made a mistake somewhere. It's not looking good. No, it's looking fine. I had it wrong in my head. Dang, that mental math. 7 and negative 20 give me negative 13x. We're going to subtract this 8 to the other side and get 0. So we're going to divide by negative 13 and find out that x is equal to 0. Now what do we do? Figure out what y is. Well, y is 5x minus 2. So 5 times 0 minus 2. 5 times 0 is 0, so that means that y equals negative 2. So that means that ordered pair is going to be 0, negative 2. All right, 14. What's different about that one? They're both equal to y, so now what happens? I'm making more of a deal out of it than it actually is. This is actually kind of nice. I know they both equal y, so in reality that means they both have to equal each other, or I could just take 1/3 x minus 8 and we're going to substitute that in for y. Ew, more fractions. I didn't realize all the fractions we had here. This one's ugly. 1/3 x. Are there? Well, it's a good thing we're stopping after 15 then. 1/3 x minus 8. We substitute that in for y, and then we have 3/5 x minus 12. Decisions, decisions, decisions. All right, we'll subtract the 1/3. So now up here, I'm going to have to go back and. Okay, so. We're going to subtract that 1/3 x. You know what? I'm not going to. I refuse. Okay. Here's what I'm going to do. I'm going to take it, I'm going to multiply everything by 15. Now, why did I pick 15? My two denominators are 3 and 5. What is the smallest number that 3 and 5 go into? 15. So that's why I'm going to take everything times 15. How many times does 3 go into 15? So now this becomes a 5x. But then the problem is I've got to take 8 times 15. Let me know what that is. Okay. Now this one, though, I got to take 15 and divide by 5, which is what? What's 15 divided by 5? 3, but then there's a 3 on top that I have to multiply that by. So 3 times 3 is, so this is 9x minus, oh my, 15 times 12. Anybody? Thank you. Okay. So again, this became an ugly problem. I'm going to subtract the 5x over and subtract the 5x over, so that gave me a 4x. In the same step, I'm going to add the 180 over and add the 180 over, and so that's going to give me a 60. So now I'm going to hope 60 is divisible by 4. Huh. It is. It is 15. Now they're back to this step. There's nothing to say. We could have taken 3/5 minus 1/5 and done that. That would have been totally appropriate. Okay, I just don't like to do that, so I don't. What? No, sorry. Yeah, 1/3. It was much harder than that. Yeah, thank you. But now that we know that x is 15, we still have one more step to go. And that is we're going to take that 15 and we're going to plop it right up there. So I know that y equals 1/3 times 15 minus 8. What's 1/3 of 15 again? Or what's 15 divided by 3? 5 minus 8 is -3. So that means this is going to intersect at 15 and -3. Okay, we're going to do one more problem and then we're going to jump over to doing our puzzles. Vinny, is that hard to see from that angle? We need to move back. Are you okay? All right. Okay, I'm telling you now, 15 is going to be the ugliest problem we do all day. Wait, I can't say that. I don't know what the puzzle worksheet looks like. Okay, but 15 is going to be the ugliest problem that we're doing our notes. Okay, can somebody tell me why 15 is going to be ugly? Yeah. We're going to have to rearrange, and we're going to have some fractions. We're going to be plowing through fractions the entire way through this problem. Maybe not. I mean, maybe we'll have whole numbers in the end, but this is not going to be pretty. Okay. But so now we have our choice. You're going to solve for x or y. Here it really doesn't matter. I always typically want to solve for, like in this one, I solve for y. This one's all right. There's only one problem here where I had to solve for anything that was going to be a nightmare. Somebody pick one, x or y. Well, actually, here, I'll tell you what. I'm probably going to choose. I know it's going to happen, so it doesn't matter. I'm going to solve for this y right here. So what am I going to have to do here? We're going to subtract the 3x over. So remember back in chapter 2, we were solving for variables. Again, it was just a precursor for what we were going to have to do later on. So we were solving for a variable again. We are taking this expression, 3x minus 4y equals -1, and we are solving for y. So I'm going to subtract the 3x over. Now, it does not matter if you write -3x minus 1 or whether you write -1 minus 3x. That is irrelevant, okay? I just like to write my variable first. We're going to divide by -4, divide by -4, and divide by -4. So we end up with nope. Positive 3/4 x plus 1/4. And to be bluntly honest, I chose that one because I knew we were going to end up with positives. But yeah, because we're going to take 3 divided by 4, so that's a 3/4 x. 1 divided by 4 is just going to be a 1/4. Okay. Now, because, and we're still going to get ugly, because I took and I isolated this equation, I need to substitute into this second equation. Okay, that's the process that has to happen. So we're going to have 5x plus 2 times y. Well, what is y? 3/4 x plus 1/4. I told you this problem was going to be ugly. It is. Got beat with the ugly stick. Dang. Okay. Now what? Well, we got to get rid of those parentheses like we have been doing. But I have to know, what is 2 times 3/4? It is 6/4, wherever that came from. But 6/4 is going to reduce. We could take the 2 into the 4 twice, and it's going to reduce down to 3/2. So we're going to go ahead and write 3/2. You're right, it was 6/4. We're going to double the top number. Has 6/4, though, reduces down to 3/2. So that's why we're going to write 3/2 x there. Just like 2 times 1/4. What is 2 times 1/4? 2/4, but then that reduces down to 1/2. Very good. Now we hit a fork in the road. You can keep on plowing with those fractions, but I don't want to. So I'm going to clear them by multiplying by 2. And again, you don't have to multiply by 2. I just don't like to play with fractions, so I'm going to multiply to eliminate the fractions. Okay, now I have this. I have x's to put together and a constant. So 10 and 3 give me 13x. We're going to subtract the 1 to the other side to get 13. So that means when I divide, we find out that x equals 13. And now what seems like a lifetime ago, when we started this problem, we have found out that x is equal to 1. So the thing is, I don't want to say I'm halfway done. I'm more than halfway done, but I'm only halfway solved because I need to figure out what? You got to figure out what y is. What's times 2? I'm lost. What? Okay. Now we're going to take this 1 and we're going to run it up right here. So we end up with 3/4 times 1 plus 1/4. What is 3/4 times 1? 3/4. What's 3/4 plus 1/4? 3/4 and 1/4. 3 plus 1 is 4. So this is 4/4. 4/4 is the same thing as 1. So that means that these intersect at the ordered pair 1, 1. Okay. I know I said 15 was the last problem that we're going to do. It's the last, just a blow-up problem. We're going to jump down and do 19. All right, so we need to do 19, and then we'll jump over to our puzzles. An adult ticket to a museum costs $3 more than a child's ticket. When 200 adult tickets and 100 child tickets are sold, the total resulting revenue is $2,100. What is the cost of a child's ticket? All right. So we're going to let the adult ticket be X. We're going to let the children's ticket be Y. So our first sentence is, an adult ticket to a museum costs $3 more than a child's ticket. So we need to write an equation to represent that sentence. There's multiple ways to do that. What? So I'm going to tell you, I say we write it as x minus y. Now you have to figure out what is the rest of the equation. What did it tell you? An adult ticket is how much more than a child's ticket? So let's say this is 10 and this is 7. 10 minus 7 is 3. There's a $3 difference there. So there's equation number 1. X minus y is equal to 3 because it said an adult ticket was $3 more. What's that other equation going to be? I'll tell you now that it equals $2,100.
200x plus 100y equals.
And there we go. So this is going to be able to dealing with money. We have 200 X tickets, and we have 100 Y tickets, and together, all the money generated from those tickets is going to be $2,100. Okay. Now we're ready to go. We're ready to solve this. We have two equations. They have two variables. So what do you think our first step should be? Anybody? Isolate. What do we know? What should we isolate over there? The x. We'll just add the y over. Seems like a great plan. X equals y plus 3. Now what? I hope we're engaging here, not just randomly sitting here, letting the day pass me by as I wiggle my pencil on my paper.
Put in that equation for the x.
Yeah. We know that x is y plus 3, so we're going to take this y plus 3 and we're going to stick it right there. All right, can we finish this? What's our next step? We have some like terms we need to collect. I've got a y here and I've got a y here, so we're going to put those together. 300y plus 600 equals 2,100. Again, we're going to try to isolate that y, so we're going to subtract the 600 over. And divide that 300 out of there. I'm going to have zeros cancel, so 15 divided by 3 is. So again, we can, again, we have no one variable. We can take that one variable and we can put it in for y there. So x is equal to 5 plus 3. So that means that 8. So that means that, and actually, did we have to do that? What did the question ask us? What is the cost of a children's ticket? What did we end up solving for when we solved for y? A children's ticket. So we didn't have to back substitute that. That was y equals 5 is my answer. Okay. Let's look at your first puzzle time. So unfortunately, the puzzle time does page 1. Yes, we can do half our work there, and then you're supposed to show your work on that graph paper. So you need to turn your graph paper in for your work for puzzle time number 1. So don't forget that. But we're moving on to puzzle time number 2. Unfortunately, in puzzle time number 2, there is 0 room for the work I want to see. So that means I need to see your work on another sheet of paper. So please, on another sheet of paper, please clearly label it as 5.2 puzzle time or something like that. Okay, just so I can, it's going to be easy. It's, again, not making it easy for me to check. 5.2 puzzle time. We can call it 5.2 PT, but there's not enough work here. Not enough room here to see work. Next time, we'll try to do something. Yeah. What? Yeah, you can if you want. I mean, you're going to end up, by the time we get through it all, there's not, I mean, you're going to need a piece of paper at some point, but that's fine. So I'm going to do letter A with you. Where am I going to do letter A at? I don't know. There's not enough room on here for sure. Actually, why don't you try to do A on your own? And then we'll come in and check it and see how you did. Alrighty, let's shut this down.